Alright. We have a target of dividing a fraction by a fraction. This is actually quite simple. There's just one little trick to do. Here's an example. 1/3 divided by 2/5. Okay. The first step, we simply rewrite the expression, and what we're going to do is flip that second fraction around. So instead of 2/5, we put the 5/2. And then the last step, before we do the math, is to change the division sign to a multiplication sign. And we learned about how to multiply fractions. You just multiply the num times num. 1 times 5 is 5. And denom times denom. 3 times 2 is 6. And if you're able to simplify it with a common factor in the num and denom, you can do that, but this one is already in its most simplified form. So 5/6 is your final answer. Now, what I would really like to show you, go ahead and copy this example down if you didn't already. I want to know why this works as a mathematician. I don't want to just memorize rules. I want to know the reasons why these little tricks work. Watch this. It's kind of like magic. Now, if you want to write this down, you can, but this is just a little bit deeper thinking. 1/3 divided by 2/5. Isn't that the same as this, right? We said before that the fraction bar means divided by. We could just interchange those words. So 1/3 divided by 2/5 can be written just like that. Now, there's another little thing we learned, and you might have learned it before, that anything divided by 1 will be the anything. So if we treat that fraction bar as a division sign, we could turn this denominator, the denominator now is kind of 2/5, it's that whole fraction. We can make that a 1 by multiplying it by the flipped version of it. Okay, watch what happens if we do this, times it. So 2 times 5 is 10, 5 times 2 is 10, 10 divided by 10 is 1. What we just did is make that whole complete denominator 1 by just flipping the fraction that's already there and multiplying. Now, the do-do rule will follow us the rest of our life, so we can't do something to the bottom part of the fraction, the denominator, without doing the same thing to the top. So, what did we do to the bottom? We multiplied it by 5/2. Therefore, we have to multiply the top by 5/2. Okay? And we would get 5/6. Now, the whole thing that's happening here, I'll circle it so we can see a little better. It's 5/6, or 5/6 divided by 1. And that kind of looks like a continent that I just drew. But we know anything divided by 1 is always the anything, whatever the thing is. And in this case, the thing happens to be a fraction of 5/6. Okay, this was a lot more work. We don't have to do all this. Okay, I just wanted to show you the mechanics behind why this little trick we did here will get us the answer every time for a division of fractions. A couple more slides here. There is an important term called a reciprocal. Reciprocals are two numbers. Should have an S there. Two numbers are reciprocals of each other if their product is 1. And we're mainly going to be dealing with fractions here. So if you look at 2/3, the reciprocal of 2/3 is 3/2 because their product is 1. We could prove that. Product means multiplication, right? So 2/3 times 3/2. Multiply 2 times 3 is 6. 3 times 2 is 6. 6 divided by 6 is 1. Therefore, these fractions are reciprocals of each other because their product is 1. The simple way to think about it, and we want to write this down in our notes too if you didn't already, is any fraction you just got to flip. So let me just write another example in the little space I have here. Okay, I'm just going to make up a random fraction. Let's say, I don't know, 7/8. I flip that. Instead of 7/8, I go 8/7. Okay? You're just flipping the numerator and denominator. Now, if you were to multiply them, you're going to get a version of 1. In this case, it's 56/56 because 7 times 8 is 56. 8 times 7 is 56. Okay? and any number divided by itself gets us 1. So that's just a little rule that a number multiplied by its reciprocal will give us 1. And we're going to use that reciprocal rule. Here I said to flip that second fraction. Flipping that fraction means taking the reciprocal of that fraction. Okay? So let me skip around a little bit here. We just want to do a little practice with reciprocals before we move further. So find the reciprocal of, and please write these examples in your notes as well. 8 over 9. Well, same thing we just did. You just flip the numerator and denominator. Reciprocal of 8 over 9 is 9 over 8. Now 2 as a whole number, this is going to get a little trickier. Okay, what is the reciprocal of 2? There's nothing to flip there. But remember, whenever there's a whole number, we can always assume that number is over 1, or 2 divided by 1, which would just get us 2 anyway, right? But in this case, it helps us flip it. Now we could easily see that the reciprocal of 2, or 2 over 1, is 1 over 2. We just flip the num and denom. And if we were to multiply those, we would get 1. And that kind of proves something as a reciprocal. Okay. 8 times 9, 72. 9 times 8, 72. 1 and 1. Okay. I'm going to skip this indie work page. We're going to do more indie work in a little bit. But I want to do 2 more examples, and then you guys can get to your indie work. Here are the steps I would like you to write in your notes, and 2 more example problems. So the 2 steps that we do, we take the reciprocal of the second fraction. Then we multiply those 2 fractions. And then the third step is always, no matter what kind of math we're doing of fractions, is to simplify the final answer if we need to. Let's do this first one, the blue one. 3 over 4. Okay, I'm going to take the reciprocal of that second fraction. Instead of 2 over 3, I'm going to write 3 over 2. I'm just flipping this around, okay? And I'm going to change that division sign to a multiplication sign. That's the second step, okay? Now you just multiply fractions, which is pretty simple. 3 times 3 is 9. 4 times 2 is 8. And we want to simplify it. In this case, we have an improper fraction. You never want to leave a fraction improper. So we can see that 1/8 goes inside of 9 with 1 left over out of 8. We've talked about how to change improper fractions to mixed numbers before. Okay, so if you need a refresher on that, try to spend your own time on Khan Academy or IXL just searching up those terms, improper fraction into mixed numbers. Let's take the second example, the yellow one. Sorry, it's getting a little jumbled here. Let me try a different color. 1 over 7 divided by 10. Now we have that situation where we have a whole number. My advice to you is put the whole number over 1, and then you could easily see the reciprocal is just flipping it. So now you have 1 over 10 instead of 10 over 1. Our second step, we change it from division to multiplication. Okay, and now we have 1 over 70. Okay, you cannot simplify that anymore. There's no common factor of both those terms. I'm sorry, of the numerator and denominator. 1 over 70 is just what it is. Just an extra little bit of knowledge that you don't have to write in your notes, but you can think a little bit deeper about. 1 over 7 divided by 10. Think about what we know about division before. Let me just give you a small little problem down here below on the right. 6 divided by 2 is 3. We know that. That's the same thing as saying how many 2's fit inside 6. How many times can you count by 2's and get to 6? 2, 4, 6. It's 3 2's that make 6. Okay? That same rule is not going to be any different just because we're talking about fractions or division of fractions. This is 1/7 divided by 10. Okay? How many times can 10, how many 10's can fit inside 1/7? Okay? And the answer is here, 1/70th. Okay, because if you did the opposite, 1/70th times 10, you would get 1/7. Okay? That was a little tricky. I think I explained it a little bit confusing. if you didn't quite follow that, it's okay. It's not going to be quite related to independent work. It's just a little bit of extra way to think about what division really is. Okay, oh, last one. Sometimes you'll see a mixed number as either the first or second part of the expression. Before you do the division, you want to make sure you change that mixed number into an improper fraction. So here we have 1/4 divided by 1 2/3. Okay, 1 2/3 we want to change into an improper fraction, which would just be 5/3. If you remember those rules, 1 times 3 plus your numerator, and your denominator always stays the same. And we have 1/4, and it's a division problem. I would do one step at a time. I wouldn't try to flip it at the same time, but since it is a division problem, we are going to have to flip that second fraction. That's our rule. Flip it to its reciprocal. 5/3 is 3/5 as a reciprocal. We change that division sign to a multiplication sign, and then we multiply through. 3/20. Nothing to reduce there, nothing to simplify. Okay, here's your indie work, page 159. Exercise 8E. You'll see it right there. Number 1, B, D, F, H, J. Basically, I'm just skipping every other letter starting with B. And number 2, B, D, F, H. Should take you maybe 15 minutes to work on that.